Hello class, I'm here to talk about the second distribution shown under chapter 4. I'm going to try to be as fast as I can on the video. If you need to go ahead and repeat the video, I did the same thing with the binomial. I have put the um, formulas over here in Excel so you can see that it's really not that bad if you use the formulas. I don't plan for you to learn every single formula in here. So what are we gonna do? We're just gonna go over the basics, and then we're gonna go and do a problem that I'm gonna be assigning for your homework. The main thing is that the binomial distribution is different from the hypergeometric distribution in the meaning that with the binomial, we're going to do with replacement and the trials are independent. And if you ask what does that mean, go ahead to the characteristics, which is right here, the most important, the end trials are independent and they are repeated using identical conditions. Think of this as drawing with replacement. That means you have 5 cards in your hand and you did a trial, you put that card back in your hand, and then you have 5 cards again. The hypergeometric, you have 5, you take one, you have 4, you take one, you have 3, so far and so on. Okay, so go ahead and read all the definitions if you need, and right here is going to tell you about P, which is considered the what they call the probability of success, and then F for the probability of failure, which is the difference. So if you do 100% or 1 minus 0.6, then you're going to get 0.4 or 40%, which is the difference. It also tells you about how to calculate the mean in this case and the standard deviation. Okay, it's over here. So let's go ahead and jump. Uh, Look for a problem. Well, the first problem, I believe, is 50 to, here we go. 52 is the first one for binomial on page 226 of the new book. Okay, so let's go ahead and let's copy. Let me see if I can copy all this over here. I think this is a different problem. Okay, let me see how that's gonna look in Excel. Over here, I'm gonna put it over here. Oh, okay, that's not as so bad. I'm gonna get rid of this one. And I'm gonna get rid of this one. Okay, so let's go ahead and try to do this problem using right here this formulas, and you see how easier that's gonna be. The formulas over here again, you're gonna see a false and a true. A false is gonna be when, let me move this even further right here. Okay, so the false is gonna be when you're trying to do a value of x exactly to a value you have determined, and the true when you're trying to get a cumulative value for x. So for example, if I right here at most, if you're working with at most or at least, you're gonna have to use this formula. Okay, if you do at least, you're gonna have to subtract the difference of the at most. But again, sounds very complicated, but let's just see how simple that is. According to a recent article, the average number of babies with significant hearing loss is approximately 2 per 1,000 babies in a healthy baby nursery. So right here is telling you you have 2 in 1,000 babies. So your probability right here, which is an average, is going to be 0.002. Okay, the number climbs to an average of 30 per 1,000 babies in an intensive care nursery. I don't believe we're going to be using this value. We're going to be using this value over here mostly. Okay, so suppose that 1,000 babies from healthy baby nurseries were randomly surveyed. So the size of my sample is 1,000 babies. Okay, and find the probability that exactly 2 babies were born deaf. So right here, I already have all the information I need to plug on this formula. over here. So if you wanna exactly 2, you have equals 2, okay? And if, or right here, so if we're doing exact amount, we're gonna be using this formula over here. Let's go ahead and put it, since the question is right here, over here. Let's put an equal in front of the formula. Let's go ahead and get rid of this definition over here. Okay, so binomial distribution. So my x, it's over here, right? 2, or just select. My n is 1,000, correct? From here. My p, my probability of this sample is 0.002, and I want a false because uh, I don't want a cumulative value. So if you do enter, here you go, your probability is gonna be 27%. Problems 54, I want you to solve, and I want you to tell me problem 56, but let me quickly go through the whole problem. Use the following information to answer the next 4 exercises. Recently, a nurse commented that when a patient calls the medical advice line claiming to have the flu, the chance that he or she truly has the flu and not just a nasty cold is only about 4%. So right there, we have our P, which is only 4%. Okay. Of the next 25 patients calling claiming to have the flu, we're interested in how many actually have the flu. Well, so we have our sample size, which is 25 patients, right? So, 53, define the random variable and list its possible values. Well, the random variable x, it's gonna be uh, right here, the number of the not claiming the flu, how many actually have the flu. So you can put that the random value is x is the number of patients calling and claiming to have the flu, right? And the values, well, if we're saying that there are 20 patients, it can go from 0 all the way to 25. I mean, 25 patients. It can go from 0 to 25. So x is going to be right here, this, the number of patients calling in. Okay, now let's state the distribution. The way you do that, since this is a binomial, you're going to do x for b for binomial, and then you have n, which is 25, and then you have the probability, which is 4%. So that would be my distribution, okay? So now find the probability that at least 4 of the 25 actually have the flu. At least. Right here, you have at most. Right here is asking for at least, so it's the opposite of that. So what we should do is to use this formula, so and do 100% minus the most to get our value, right? So if you're talking about 4, so you want to define for 2, and for 1. You do not include 4, okay? So we're going to use this formula over here. Let's put it down here. And let's put an equal sign. And we're doing true because we want a cumulative amount to take from the 100%. My x is asking for at least 4. So but we are using this formula to subtract from 1, so we do really 3, right? Your n over here is 25, 25 patients. Your probability is zero point 0.4, which is 4%, and it's true, right? So you get this, but remember, you want to at least, so 1 minus 1, 2, and 3, you have a about 2%, or 1.65%. It really depends how many decimals you put. Okay, now the one that you're going to be answering, on average, for 25 patients calling in, how many do you, here you go, let me put it like this, how many do you expect to have the flu? Okay, so for every 25 patients, so it's asking average. Average the same as mean, if you go to the formulas right here, it tells you how to calculate the mean or the average, which you do the sample size times the probability, and the standard deviation right here. You're going to do the square root of the sample size times the probability of success times the probability of failure. We just wanted the average, right? So we're going to do mu, it's going to be equals to n times p. So let's do equals to n times probability, which is 1. So one patient we expect to actually have the flu and not just a nasty cold. So again, you're being assigned problems 54, which is to state my distribution. And you also have been assigned problem 56, which tells me the average of how many actually have the flu. And we will be done with the binomial distribution. If you want to go over the problems on your own, that's fine, but I don't expect anything else for that distribution. Thank you.